Hello, everyone. This is a continuation of chapter 3 of our database course. So today we will be looking at some more SQL queries. Let's start with the rename operation. The SQL query allows renaming relations and attributes using the as clause. So you have the old name and then as new name. Here we have an example. Find the names of all the instructors who have a higher salary than some instructor in computer science. So the query says, hey, select distinct t.name. T is basically renaming it. We are renaming instructor table as T. So that's one table. We also have instructor table as is. So we have two of the same tables. And we are getting the names from the first table. And we're comparing the salary from the first table with the second table and say department should be, from the second table, the department should be computer science. So this is basically telling us finding all the instructors who have higher salary than computer science faculties or computer science instructors. The keyword as optional and maybe omitted. So instructor as T, or you can say instructor T. These are equivalent. So if you remember the student example that we had, we can write similar queries. So here we can write queries like, hey, select distinct names from student table. So there are two student tables that we are thinking. First student table, we are picking up all the names from the first table, where we are also having a second table with all the student names. But from the second table, we are looking at we're comparing with the total credits. The first table students total credit should be larger than the second table students total credit, and second table's department name should be computer science. So we're looking at basically this query. What it is doing is this query selects the distinct names of students who have more total credits than students in the computer science department. It compares the total credits of students across the entire table filtered by computer science department. So this is an example of the rename operation. And this next we go for self-join example, relation EMB and super. So find the supervisor of Bob, find the supervisor of Bob. Then we need to join this two table join this table together. So for example, employee and supervisor relation. This is person Bob who has a supervisor Alice, but Alice is also a person in this table, and Alice's supervisor is David. So we're asking, hey, who is the supervisor of Bob? And then we're asking, hey, who is the supervisor of Bob? That means from this table, we can say, hey, Alice is the supervisor of Bob, but we need to join this table together to see who is the supervisor of Bob. Then we get, hey, Bob supervisor is Alice, then Alice's supervisor is David. Similarly, we can, if you remember about the student example, let's run a query. What this query does is select student's name as student, and then student 2, same table, student 2's name as student with more credits. From first student is first S1 is student table 1, and then join with the same table, student table as S2. So we are renaming the student table as S1 and S2, and then we are joining these two tables together. And then we're saying, hey, join these based on what condition? Based on student's department name, and S2's department name should be same, and students one's total credit is less than student 2's total credit. So what this query does is the query selects students S1 who have fewer total credits then another student S2 with the same department. So within the same department, it returns a list of students and other students in the same department who have more credits than them. If I run this query, this will, okay. It's giving me some error. Oh, it went away. So Alice and student with more credits is Emma Wilson. If I want to see the total credits, it will make more sense. So for example, let's say for S1 dot total dot grade, comma, I want to see S2's total credit as well. S2 is basically the same table, but we renamed it as S2. So now it sees Alice Johnson has 30 credits, Emma Wilson has 40 credits, Alice Johnson has 30 credits, Tina King has 50 credits. So on the left side for the student S1, we have smaller credits, student with more credits on the right side, but it's within the same department. So this is an example of self-join. Then we have string operations with SQL. SQL includes a string matching operation for comparisons on character strings. The operator like uses patterns that are described using two special characters. So the percentage character matches any substring, and the underscore, this underscore character matches any character. Find the name of all instructors whose name includes the substring DAR. So select name from instructor where name like percent DAR percent. So in their name anywhere, if they have DAR in their name, that should come up. Let's run this example with our student table. So hey, I have written a query where I want to find all the student names whose name where name is like SON. So if they have son in their name, that should come up. So if I run this query, Alice Johnson, so they have son in the end. Emma Wilson, Henry Anderson, Mia Thompson. So everyone has son in their name. All these examples. If I change something like, hey, I want to find out all the student names who has A in their name. So yes, A. Let's say if I want to find A, I want to find all the students who has Mass in their name. There's just one, Thomas. Let's say I want to find all the students who has OM in their name, O and M, one after another. So I have OM, that's Thompson, and then OM as Thomas. So this is the use of like example. There are more examples. Pattern matching. Patterns are case sensitive. Pattern matching examples. Intro and person matches any string beginning with intro. Comp matches any string containing comp as substring. And this matches any string of exactly 3 characters. And this makes sure matches any string of at least 3 characters. So there can be 3 characters and then it can be more, but it has to be at least 3. And then there are SQL supports a variety of string operations such as concatenation using this to barred lines, converting from upper to lower case, and vice versa, finding string length, extracting substring, etc. We can also order the display in database table. We said database table tuples are not ordered in any way, but we can view them in ordered way. So I want to say list in alphabetic order the names of all the instructor. We can do this by select distinct name from instructor table. So order by what? Order by name. We may specify descending for descending order or ASC for ascending order. For each attribute, ascending order is the default. Example, order by name. Descending gives us descending names. Can sort on multiple attributes, order by department name and name. Let's look into some examples with the student table. So if I have one query where I say, hey, select all the distinct names from the student table. If I do not run this, I just say distinct name from all the student tables. So this gives me all the table names. By default, this is ascending order. If I say BASC, if I run again, so the name starts with descending order. Now we can have multiple order by multiple names. So let's try that. Here we said, hey, select distinct name and department name from student table, but make sure to order by the department name. After you have ordered by the department name, you should order by the student name as well within that department. So if I run this query, it starts with Henry Anderson. So H is not the alphabetically not the first thing that you should get. You should get Alice, but we're not ordering by name first. We're ordering by department name. So biology, this is ordered alphabetically. Biology, then chemistry, civil engineering, computer science, and within these departments, the name are alphabetical. So Alice Johnson, Emma Wilson, and Kelly Harris, Tina King. These names are alphabetically ordered within the departments. So we say department name ascending and then name ascending. SQL includes a between comparison operator. So find the names of all the instructors with salary between $90,000 and $1 million, or 100,000, sorry, 90,000 and 100,000. That is greater or equals to 90,000 and less or equals to 100,000. Select name instructor where salary between this number and this number. So let's try this example with the student example, student table. So we don't have table salary in our student table, but we do have credits. So hey, give me all the student name from the student table where the total credit is between 40 and 60. So everyone that is taking 40 or between 40 or 60 credits, they gave me the name. But how do I know that it makes sense? If we can see their credits, it would make more sense. I want to see total credit there taking. So if I run this, now we see this is between 40 and 60. This is we have students with less than 40 credits, like 30 credits. That's not shown in this table. And anything above 60, that's also not shown. Let's try this with 50. So if I run this, now Bob Smith shouldn't come up in this table. If I run this, Bob Smith is not here anymore. So as well as a lot of students are also not in here as well, who has taken more credits than 50. We can, there's another example here, tuple comparison. So what tuple comparison query does, let's run one query with tuple comparison. So this is an example of tuple comparison. This query compares the tuple student ID and student department name to the tuple takes ID and computer science, and selects the name of students whose IDs match in both tables and who are in computer science department along with the course they are taking. So if I run this query, this is all the students that are in computer science along with the course they are taking. So this is basically tuple comparison. Now let's look into some set operations. In our relational algebra, we saw union operation, intersect operation, and except operation. We did have quiz on them as well, but now we are going to see how the set operations can be used in SQL queries. I do have some query written here. So this is basically two different queries. One, this is saying, hey, give me all the course ID from the takes table where the semester was fall and year was 2024. And this is another table that says, hey, give me all the course ID where semester was spring and year was 2024. But what we're going to do is we're going to say, combine these two tables and show me one table. So this is it, showing one table. Let's try this. Select Uh, so this is union operation. We can say similar to union, we can say intersection, we can say all, we can run except operation. So except operation will do is whatever was offered in fall 2024, show only that and do not show what was offered in spring. Just fall, but not in spring. So this is the courses that were offered in fall, but not in spring. These are example of set operations. Set operations, union, intersection, except each of the above operation automatically eliminates duplicates. To retain all duplicates, use union all, intersect all, and except all. So it will not eliminate the duplicates. There can be null values. It is impossible for tuples to have a null value denoted by null for some of their attributes. Null signifies an unknown value or that value does not exist. The result of any arithmetic expression involving null is also null. So 5 plus null returns null. The predicate is null. The predicate is null can be used to check for null values. Example, find all instructors whose salary is null. So we say select name from the instructor table where salary is null. So this will give us all the faculty instructors names where their salary value is not there. The predicate is not null succeeds if the value on which it applied is not null. So as you can see, comparing any value with null returns unknown. This is because SQL doesn't know the value of null. Now let's see how Boolean logic deals with null using and or or. Using and or with null, the result can change based on whether we are comparing true or false. So null in SQL means unknown. Any comparison with null results in unknown. In and operation, true and unknown is unknown, false and unknown is false. In OR operation, true or unknown is true, and then true or false and unknown is unknown. So when you see null in a condition, SQL treats it as false if it evaluates to unknown. There are different aggregate functions we can use in SQL. These functions operate on the multi-set of values of column of a relation and return a value. So we can do average value, minimum value, maximum value, sum of values, number of values. So aggregate function example, find the average salary of instructor in computer science department. So you say select average salary. So this will average all the salary where instructor, from instructor table where department name is computer science. Find the total number of instructor who teaches the course in the spring. So you say select count distinct ID. So you count all the faculties from teachers where semester is spring and year is 2018, and find the number of tuples in a course relation, like select count everything from course, how many courses offered. If we can do this, we can do this with the student table as well. For example, if we want to run, hey, I want to see, let's say, average of total credits as average credits from the student. So how much credit students take on average? That's 53.5 credits that students are taking on average. Now I say I want to see total credits they're taking, but I want to see what is the minimum credit a student is taking, mean credits. So we have an aggregate function for that is called mean, and then total credits from student. If I run this, so minimum credit the student is taking is 30. We can also see what is the maximum credit one student is taking. We can run operation like max. If I run this, 80 credit is the maximum credits a student is taking. And we can say, hey, I want to find the total sum of credits of all students. How many credits are being offered or students are taking in all together. If I run this, total students, everyone combined, all the credits they're taking is 1070 credits. I want to say, hey, count the total number of the students. How many students are there? That is count everything as total students from student. There are total 20 students. So these are the example of aggregate functions. We can do aggregate functions based on group by. So find the average salary of instructors in each department. I can find average salary from the whole instructor table, but I can say, hey, I want to find average salary from individual department as well. So for example, here, biology department, this is the salary. So it's one faculty, so that's average salary is this one. Computer science, this is the salary, and I want to say what is the average salary for computer science. This is this one, plus this is adding this three and then subtracting by three. Same thing we can do with the student table. I want to see all the credits students are taking based on their department, like how many credits each department students are taking on average. So the query is, hey, select department name and then average of total credits as average credits from student group by the department name. If I run this, biology students are taking 47.5, business students 72.5, so business students are taking more credits. Chemistry 60, civil engineering 50, computer science 37.5, and so on. Um, for aggregation, attributes in select clause outside of aggregate functions must appear in the group by list. Find the names and average salaries of all departments whose average salary is greater than 42,000. So select department name, average salary as average salary from instructor table, group by department name. And also we are saying having average salary is greater than 42,000. We are adding one more condition here. Predicates in the having clause are applied after the formation of the groups, while predicates in where clause are applied before forming the groups. So having will apply after you form the groups by group by department name. So for our student example, I want to say, hey, I want to write a query that groups by department name and then calculates the average of total credits for each of the department. And then I want to say the having clause filtered only those department where the average total credit is greater than 40. If I run this, select department name, average of total credits, and average credits from student group by department name, having average per credit is greater than 40. If I run this, so you see computer science is not there anymore because computer science students average, on average, they were taking less than 40. There are more nested subqueries, and we will look into those nested subqueries, set membership, all these in our next class. So thank you.